Hey, I just thought I would make this quick video talking about how to learn or how to go about learning 6502 assembly specifically for the Apple IIe in 2024. And my name is JakeOUT. So to get started, let's take a look at this game, JakeOUT. JakeOUT is a ripoff of Breakout, but it's actually a pretty nice little game. And here it is. And you might think it's looks a little creaky, and you're right about that. It's not perfect, and but as far as versions of this game for this computer go, this is not that bad. And there is a level editor built in, so you can edit your own levels. And so endless fun. And so this was my project for learning 6502 assembly, and I started out programming this game in AppleSoft Basic and then compiling it with the AppleSoft compiler task, and that got to be clunky, and then I was writing a lot of my own routines anyway, so I was just like, you know what, I'm just gonna go full assembly language programming and I'll solve all the problems I need to solve along the way. And that turned into probably like a 3-month project after it had already been probably an 8-month project before developing all the AppleSoft code first. So it doesn't look like much. It's not that impressive, but it does. There a lot went into it, so I don't care if it looks like it sucks, because I don't think it sucks. Okay. That being said, I'm getting a little too into this game right now, and you're seeing it at a reduced frame rate, so you're not seeing every frame that I'm seeing. Because my video capture is not that great, so keep that in mind too. That it looks very smooth, what I'm seeing, and it's quite fun to play. And there's you can play with the keyboard, or there's 2 joystick modes. The one I'm using, the joystick mode I'm using right now, has like a self-centering, so as the joystick centers the joystick. I'm talking too much. Okay. Oh, I have a high score. Okay. Oh, my caps lock wasn't on. Okay, let's take a look at the source code. So here's the index. These are the addresses where the code resides. So you can see I have a lot of subroutines, and I have subroutines that call other subroutines. And so this is my main library, and every function has a subroutine. And then these are the main code modules that call the subroutines for the most part. And these are some patches to fix bugs and otherwise enhance my code, and they haven't been integrated yet, so they're just sort of patches that are sitting on top. And here are the built-in subroutines that I've used, and I learned how to use these subroutines by reading these books. So we have the assembly language tutor is really how I got started. It really is what got me started in the first place, and just got my first leg into assembly language programming. And this book is great. It takes you, even if you don't know anything about it, it teaches you all about binary and hexadecimal first, so it's a great starting point. And then the best thing about it is it provides this program here, the assembly language tutor, or it's called something like that, and I can enter programs So this program will load a 7F into the accumulator, which you can see up here. This is the accumulator, the X register, and the Y register. And this is the 3 registers of the 6502. This is the status register, and this is the stack. So let me single step through these instructions. Load accumulator 7F. You can see that the accumulator loads. Then you store the accumulator in location 308, which is here. So we should see a 7F be placed in this location. And there we have it. And that's the program. So we just put a 7F in this location. So as you can see, this is a very powerful tool. You could have self-modifying code, or this is just how you can manipulate anything you'd like. And that is done with this instruction set, which is here in the Beagle Brothers poster, which is also found in the archives at apple2.org, mirrors.apple2.org, and we have so basically you would go to mirrors.apple2.org.za, and then you would go to ftp.apple.asimov.net, and then documentation, and that's where you have all your books. Everything you want to know is in here. Hardware specific programming, everything. It's great, and it's all at your fingertips for free. Everyone has access to this. Emulators, the emulator I'm using right here is Apple IIe. So then you have all your disk images, all your games, and programming utilities, things like that. So it's just a great repository of information, as well as the Internet Archive. And that between those two places, I found all the books that I use. And the other books I use is the AppleSoft Reference Manual, the DOS Reference Manual, and Assembly Lines, and Inside the Apple IIe. And I'm pretty sure all of those are found where I just mentioned. And this one I had to dig for, but I heard about this one in one of those books, and this is just a document documenting the AppleSoft internal entry points. It's a pretty concise little document that really provided me with some insight into using the floating point math system, and just basically everything that you need to know. So I basically started out with a problem. My problem was I wanted to turn all this code into assembly language. All this AppleSoft code that had to be compiled with task, and then I had to load the task runtime library, and it was all it was a lot of overhead to play this simple game, and I wanted to reduce the overhead. So, and speed things up in the process. My code is faster than the compiled task code. So you can see a code block like erase block. I just wrote these each one line at a time. I wrote in an assembly language machine to accomplish the same task. So if we check out my source code, and we have erase block, and you can see that it's the same line of code. Oh, I have the wrong one highlighted, but you get the idea. And I use my own divide and multiply routines that I set up ahead of time. So let's check out those, the divide and multiply routines. Where are they? Here we go, divide and multiply. So this is my little divide machine, and you enter the program with a containing the numerator, and Y register contains the denominator, and when all is said and done, it returns, and A holds the result, the integer portion, and Y contains the remainder. And it's actually, if you look at it, the division is accomplished with addition, believe it or not. I don't remember exactly how I did it, but yeah, addition is what gives you your division, believe it or not. And the subtraction is used for the remainder. Yeah, yes, because it inverts the number. Yes, here's the inversion. It inverts the number first, and then it adds. So it's like yeah, it's difficult to explain, but I can see how it works. And then the multiply, you have an A in the accumulator and a Y in A contains the numerator and Y contains the denominator. And then after, when it returns down here, X contains the high byte of the result, and A contains the low byte, because it's a 2-byte number that you'd need in order to be able to multiply A times Y 1 byte at a time. Here's my collision detection algorithm. Sound, this produces a beep of pitch and length. Here's my character generator that allows me to print text onto the high resolution screen. My joystick functions, my two modes of joystick mapping. So it maps the input to the output, gives you different control options. In this boundary check, it keeps you within the boundaries of the rectangle that you play the game in. These are subroutines that are used in level load, and this is the level loader, and this is what draws the blocks on the screen from a data file that's stored on the disk that you can create using the level editor software that's included on the disk, and you can see. So what is really important is the comments. After you do a line of code, you should always put a comment. Always. Unless it's self-evident. But and your comment should explain why you're doing what you're doing, not just the what. Because we can look at the code and determine the what. The why is more elusive. So keep your comments good, and it'll pay off down the road, I promise. And you don't want to write code that you don't have to write, so use built-in functions where appropriate. And you can hijack the AppleSoft system to and use a lot of the built-in AppleSoft routines to accomplish things too, like variable storage and variable management. But my program didn't use that because I didn't feel like learning that. So and I wanted to use my own system. So I have my own string handling routines. We could take a look at. So strings are stored like this on this page. These are the string constants. So every time it prints some text on the screen or DOS commands, it needs to get it from somewhere. So this is the data that actually spells out the words in ASCII. These are the ASCII values, which are found on this chart. Not that chart, this chart. Beagle Brothers, Apple colors. And these are the high-res colors. So these are my color palettes that I was using. I was using this color set and then that one. Yeah, so you can see here's my high value and low value. So when the key is pressed, it's the high value, and then when the key is released, it's the low value. But they represent different things. You would use the high value for certain things and the low value for other functions, just by convention. And this chart is some useful addresses. These are some built-in functions. this is your read keyboard and clear keyboard switches, reading the paddle and things like that, and your graphics switches, and as far as like your vertical tab position and horizontal tab for printing on the screen is 24 and 25. D8 I had to reset as part of the error handling functions. So yeah, and back to the strings. So then there was a print string routine, which the Y register is loaded with the address of where you want to. Like say I want to print JakeOUt, it would be 11 would be loaded in the Y register, and then you call the print string routine, and wherever V tab and H tab point to, it will print that using this loop. And then in moving strings around and from the input buffer and things like that are all handled, and reading text files. So that's there. So you can see that there's a lot going on, but not a single byte is wasted. And if we go all the way to the bottom, 4,578 bytes. So. And I didn't use an assembler either. I actually haven't used an assembler yet, but I think that would be the next step, is because if I make anything more complex than this, I would want to use an assembler. And you're like, how did you not use an assembler? Well, I just typed in these values just into the monitor, and I could show you. So if I just boot System Master. Oh, it has to read off of a external drive, and it takes forever. Come on. Yes. So to enter the monitor, you would go call -151, and then this asterisk means that you're in the monitor, and we could view an area of memory from 300 to 380. That's half a page, and there's nothing here really on the that's a great spot to put little short assembly routines. And so if I go 300 colon A9 7F 8D 08 03 60 to return. And then we go 300L, that'll list it, and you can see that it breaks it down into the instructions. So load accumulator with 7F and then store it in 308. So after we run the program, we should have a 7F appear here, and we run it by going 300G. And now if we list 300 again, 399, oh, I can't see what I'm doing. 300 listed looks like this, and here it is, 7F. So the program did its job, and it's that simple. And then if I wanted to save this to a disk, I just have to have a disk loaded that I want to save it to, and I would use a command like b save, then the name, comma a 300 comma L, and then you would count the number of bytes. It would be, but if you started at 0, then it would just be 5, and then you add 1, so 6. So at length 6. Oh, but it hex 6. And then when you saved, it would save it as name, your program, and then you could load it, and it would load and run, or no, it would load it, and then you could run it with a call 768, which would be the decimal equivalent of 300. And if you use the b load, or I'm sorry, the b run command instead, it'll start the program at the first byte loaded. So that you can only use brun if your program starts from the beginning. Mine doesn't. Mine starts at 17b5. But anyway, so if you look at what I have, it's complicated, but it's not that complicated. And if you use subroutine smart, you like here it's loads v3.0 to print it on the screen, but then the next thing it has to print is by JakeOUT. So when it finishes printing this, the Y is already where it needs to print the next thing in memory. And so so by lining them up in memory in a smart way, my code is even smaller because I only need this one little increment Y instruction in order, instead of loading a whole new number. Just little things like that can make your program more elegant. And the game over section was probably my longest bit of code, because it has to compare the high score, or compare your score to all the high scores in order to see if you got a high score, and if so, where to put it, and to modify the high scores list. So there's a lot that goes on. You might think like, oh, it's just game over, so it doesn't really need to do that much. But if you want it to be like an arcade game, it's actually, that if you look at that, that's a lot of code. And the code, you might ask, how do you write the code? But it's just like the code writes itself, like similar to how a Sudoku puzzle would fills itself in if you just sort of you know what the beginning looks like, and you know what the ends look like, so you start writing it from the beginning and the end, and eventually they meet in the middle. And I would compare it to instead of here, let me draw something. Here we go. Microsoft Paint. Yes. Good old Paint. So, so here's your program. And if you were doing it linearly, in order to complete your program, you would do it in a roster fashion like this. Start at one side and fill in your code in this sort of way, like an inkjet printer would. But so starting at the beginning and finishing at the end. But it's what really happens is you start writing code. Can I fill this? Fill. Yes, so you start writing code. Why didn't it fill? This program's junk anyway. I missed the old Paint. I feel like the old Paint was better. I don't know why Microsoft just makes their programs worse and worse, but you get the idea. So you write your code modules, and eventually you fill up the whole thing, and it's a much more organic process. So each one of these bubbles will be code that does one function of the game, and once you fill in the whole circle, your program is feature complete. And so I thought that was a nice metaphor. And what else do I have to share with you? So, yeah, so maybe this is interesting. So the way that I encoded the level information, the blocks that you have to break out, they're stored in a levels file, and the information is compressed as much as possible. So 1 byte represents 8 blocks. So it's in a given row, it's column 1, 2, 3, 4, through all the way through 8. And it determines whether it draws a block, yes or no, depending on if the bit is a 1 or a 0. And then the remaining, it's a 10 by 12 grid, so 10 columns, 12 rows, and so the remaining 2 columns, it's the information is encoded in a slightly different way, and that's represented in this information here. I'm not going to get that crazy into it. This is the script that allows it to boot directly from, they call it a turnkey program, so it'll boot right off the disk automatically. And so this is just some extra things. And this is my level editor, which is currently written in AppleSoft. It's not even compiled or anything because I don't really need the speed for this program. So that's what that is. And then I had a subroutine. I developed my own graphics program, so when you see that splash screen at the beginning, that's actually encoded in a graphics format that I invented. It's called GIF, JIF, or Jake's image format. And so this is the GIF file decoder, and that's the code to store the splash screen. That's the data. And so basically just it maps when you draw something using the drawing program that I invented. It stores the instructions to draw it, and so this acts like a script to draw the lines to make the splash screen. So okay, so that's all I wanted to share with you, and have a nice one.